Okay, sorry. There's a bit of camera problem. So now finally got the focus on it. Okay, so example one, it is 3.7. 3.7. Make sure you know how to do 3.3, 3.4, 5, and 6. Okay, it's all combination of those four. So take a look at A, example one. Okay, it's the basics of 3.3. So I'm just gonna move on to the next question after this. X squared minus y squared, as long as you have the even power, okay, even number power, 4, 6, or 8, or 10. If it is even power, you can do the differences of squares as long as you have two terms with negative in between, or I have different signs for the two terms, positive x squared, negative y squared. Okay, so in this case, put the two brackets around plus minus, then square root of the first one, square root of the second one, square root of the first one, square root of the second one. Okay, now B and C, I'm just gonna move on. I'm just gonna skip it. I believe you can do this on your own. Let's do something a bit bigger. So I will skip to D. So we have 9x squared minus 121y squared. Now same thing. Two terms we have, even powers. So plus minus. Square root of 9 will be 3x. Now square root of 121y squared will be 11y. So same thing. Okay. Let's move to E. Now E is something that I want you to actually think about a bit. So, as I said before you begin factoring, okay, you need to see whether there are any common factors, okay, whether there are any common factors. And from 80 and 45, there is 5. So take 5 out, then this becomes 16a squared minus 9b squared. Having said that, two terms, even powers, and different signs, positive, negative, so two brackets here. Now plus, minus, square root of 16 will be 4a. Now square root of 9b squared will be 3b. So 4a, 3b, done. Okay. Let's then move on to F. Now this is the important stuff. So I have x plus 3 squared minus 16. Now remember, this we can consider that as one term. Okay, so we have x plus 3 squared. If you're confused, then do this. Let x plus 3 equals a. So I have then a squared minus 16, but as you can see, this is a minus 4 and then a plus 4. Once you do this, then substitute x plus 3 into the a's. So then I have x plus 3 minus 4 and then x plus 3 plus 4, which gives you x minus 1 and then x plus 7. Okay, so you should be able to see this type of questions right away in terms of the solutions. Okay, so then let's take a look at G. So if you look at G, we have 100x minus 81x cubed. So in this case, if it is 100x minus 81x cubed, remember it's always have to be in the descending order. So then I have negative 81x cubed plus 100x. Then take a common thing out as well as the negative sign, the leading coefficient, meaning the coefficient of the highest power. So negative, then x, 81x squared minus 100. Now, how did I get x squared? Well, from x cubed and x, the common term is x. You should be able to see this right away, okay? So x cubed divided by x will be x squared, and that will be gone. Negative is outside, so negative 81 is negative, positive 81. Positive 100 becomes negative 100. Now, having said that, then we have, again, two terms, even power, different signs or negative. So I have plus minus, then 9x, 9x, 10, 10. Okay? Now h. H, it's pretty much the same. So x minus 1 squared. Binomial squared again. It seems like we may be able to do that special case of difference of squares. So let, if you don't see it right away, let a equals x minus 1 and rewrite it. So 4 minus a squared. And as I said, we have to rearrange it in order of a variable rather than a number. So minus a squared plus 4. Take negative out, so it will be a squared minus 4. then substitute back in. So this becomes x. Oops, sorry, not yet. So this equals a plus 2, a minus 2. Then you substitute in. Okay, so then it becomes negative x minus 1 plus 2, and then x minus 1 minus 2. So negative x plus 1, x minus 3. Okay? Now, it says fractions. Oh my god, fractions. What do I do, Mr. O? Well, don't panic, okay? Take a look one at a time. So, two terms, even power, and different signs. So, positive here, negative here. Therefore, we will have differences of squares. So, plus minus here. Square root of x squared will be x over square root of 16 will be 4. Okay, do not change anything. Just take a square root of each and then just write them down. Now, same thing for y squared over 25. So then this is what we have. Okay, this is what we have. Now, j is something that you have to be very cautious about. Okay, so we have x to the power of 4 minus 16. Again, even power, two terms, right, and minus. So we have x squared minus, plus 4, x squared minus 4. Now you should be able to see this right away. X squared plus 4, we cannot factor this anymore. However, x squared minus 4, same thing, right? So difference of squares again, plus minus, x2 and xn2. Okay, so again, even power, two terms, minus in between, then square root of the first term, which is x squared, square root of the second term, which is 4, so which is 2. Okay, there's nothing we can do to go further, so that's pretty much it for j. Okay, now then let's take a look at k. So whenever you see binomials in a different forms and so on and so, consider a case that you have to probably use different letters. Okay, so let's take a look at this. We have x minus 3 squared minus x plus 3 squared. This can be one term, this can be another term. So let a equals x minus 3, b equals x plus 3. Now, therefore, I have now a squared minus b squared. This looks more familiar to you. If I take these and factor these, I will have a plus b, a minus b. Once you factor a squared minus b squared, substitute x minus 3 and x plus 3 back into the equation or the expression. So then I have x minus 3 plus x plus 3, and then x minus 3. Now, negative, really be careful, okay? Negative, this negative basically means negative b, so it changes the sign of x plus b, so minus x minus 3. This gives me 2x. Now, this gives me negative 6, therefore negative 12x. Okay, so you gotta be careful with the question type like k. Okay, you have to, and you have to. Now then, let's take a look at example 2. So example 2 is using the special cases of perfect squares. Okay, so example 2, I will do one with you. Rest, you should be able to do it by now. Okay, you should be able to do it by now. So let's take a look at this. M squared minus 14m plus 49. Remember whether it is perfect square factoring or not. The first number times the last number, so 1 times 49, which is 49. That's the first. Second, take a square root of that number, which is plus minus 7. Third, plus minus 7 from the second step, times 2. I have plus minus 14. See whether I have one of these two numbers, positive 14 or negative 14, in the middle. I have negative 14, therefore I have a perfect square factoring. So Then just put the square here. Follow the sign in the middle, which is negative. Take a square root of the first term, which is m, and 49, which is 7. Okay? You should be able to do this with B and C. Okay? So I'm going to skip to D. Okay? Now D, actually I'm going to do it on a different side. So I have D. Let me just organize the paper. Okay. So I have D saying x to the power of 8 minus 24x to the power of 4 plus 144. Okay, so same thing goes, and this is actually a perfect square trinomial. So the middle term sign is negative. The first term's square root is x to the power of 4. Remember, if it is a square root of a exponent, it's always that exponent divided by 2. So 8 divided by 2 is 4. Square root of 144 is 12. Now, the problem is, I have two terms, I have even power, I have negative sign. So, then I have differences of squares. So, x squared, and then plus, minus, square root of 12, square root of 12. You don't have to simplify this, okay? Then, take a look at the first two. We are okay since we have positive. However, we have another contender for differences of squares. So I have even power, I have a number, I have different signs, so positive x squared and negative square root of 12. So we have to do this again. So the first thing, the first brackets will stay the same. However, the second one will be different. Remember, it is difference of squares. So plus minus. Square root of the first one will be just an x. Square root of the second one, which is square root of 12. How do I take a square root of 12? Just write square root of 12. That's all it is, okay? Square root of 12. Done. Okay. Now, let's take a look at E. E, pretty much the same thing. It's just a higher power. Y to the power of 10 plus 2, y to the power of 5 plus 1. Now, having said that, it's a perfect square terms again, so squared, positive, since the middle term is positive. Square root of the first one will be y to the power of 5. Square root of the last term will be just 1. Okay? Now, f. F is something that can be a bit challenging. So I have x squared minus 6x plus 9 minus w squared. Now, we only did 3 terms or 2 terms. 3 terms for product and sum, 2 terms for difference of squares, or for the 3 terms we have perfect squared as well. We don't have 4 terms. So if you have more than 3 terms, you may think that there's possibility of hidden difference of squares or perfect squares or product and sum. Okay? So take a look at these 3. You should be able to notice that this is a perfect square term, and that is x minus 3 squared. Okay? Now minus w squared. Now, having said that, this is a term, this is another term, you can say let a equals x minus 3, then it is a squared minus w squared. So, yes, it is a difference of squares, so a plus w, and then a minus w. Once you factor a squared minus w squared, put a equals x minus 3 into that expression again. So I have x minus 3 plus w, now x minus 3 minus w. Now you can leave your answer in this way, I don't really care. Okay, it should be all good. Okay, now let's then take a look at example 3. So example 3 is a bit of application of what we just did. So let's take a look at A. I'm going to do all these 3 with you, okay? 9x squared plus kx plus 25. Now, these 3 have to be a perfect square trinomials, right? These 3 have to be perfect square trinomial. Therefore, remember how to figure out whether a trinomial is perfect square trinomial? The first term times the last term, which gives me 225. Second step, take a square root of that number from step 1, we get plus minus 15. Don't forget the plus minus sign here. Now the third one is basically this times 2, which gives me plus minus 30. Okay, so this is plus minus 30. This plus minus 30 should be the middle term so that they become a perfect square trinomial. Therefore, k is plus minus 30. Okay, then let's take a look at B. So B says 4x squared minus 12x plus k. Now, same thing, okay? So first, the first times the last, so 4 times k, which is 4k. 2, take a square root of it, 4k. Okay, this basically is square plus minus 2 square root of k, right? Now 3, then plus minus 2 square root of k times 2. That gives me plus minus 4 square root of k. Now here, remember this, okay? This have to be the same as negative 12. So plus minus 4 square root of k equals negative 12. Then take 4, so k will be 3. Okay, 12 divided by 4, so then k will be 9. Okay. Hopefully, okay, I'm gonna do B again. I wrote everything without noticing that it is not there. So take a look at this. If the k is the part that is missing, okay, if the k is the part that is missing, do the same thing, okay, and then we get square root of 4k, but square root of 4k is simply just 2 times square root of k, and then the third step, remember, we have to multiply it by k. Therefore, we simply just have that as the middle term, which is negative 12. Now, if you divide it by the number in the front, I get square root of k. Since I am looking for the k, I have to square these two terms. Oh, sorry, it has to be plus minus 3 squared. So then k will be positive 9. Okay. Let's do C. Okay, C, same thing. Okay, so k times, it's kx squared minus 40xy plus 16y squared. So k times last, so which is 16k, and take a square root of 16k. Now the first number is 16, so square root of 16 is 4, so 4 square root of k plus minus. Then plus minus 4 square root of k times 2 gives me plus minus 8 square root of k. Then this plus minus 8 square root of k has to be negative 40. So divide everything by that number. So then k will be plus minus 8. To get rid of that square root sign, we simply just square the whole thing. So k will be 64. Okay, so once you have this, then you are good to go. Okay. Oh, sorry, I actually did wrong. This is 5. So this should be 25. Okay. Okay, so k is 25. My bad. 40 divided by 8 is 5, right? And 8. So 5 squared will be 25. Okay. So example 3, you have to study hard. Example 3 question. Okay. Hopefully this helps. See you guys on Monday. Okay.